All right. So, welcome to Chapter 7, the Virtual Private Cloud. So, in this chapter, we'll explore Google Cloud's Virtual Private Cloud, the VPC. This is the foundational networking layer that securely connects your cloud resources and services. Understanding the VPC is crucial for designing secure network architectures and implementing effective network security controls in Google Cloud. So here's an overview of VPCs. Google's virtual network is built on Google's internal production network and based on Andromeda, Google's implementation of its own software-defined network. VPC provides a virtual network environment similar to a physical network, but with enhanced capabilities due to its software-defined nature. VPC is responsible for providing connectivity to various Google Cloud services, including Compute Engine instances, Google Kubernetes Engine clusters, App Engine flexible environments, and other services built in these platforms. Beyond basic connectivity, VPC also natively provides load balancing and proxy services, distributes traffic to backend services, and enables connections between Google Cloud and on-premises data centers or other cloud providers. So, key features of Google Cloud VPC include one, global resource. A VPC network is a global resource with components like routes and firewall rules that apply across regions. Two, IP addressing. VPCs support IPv4 based subnets. IPv6 is also supported on compatible subnets, though auto mode VPCs don't natively support dual stack subnets. Three, firewall controls. Firewall rules control traffic to and from instances, allowing you to define which virtual machines can communicate with each other and on which ports. Four, default communication. When you create a VPC, all resources within the network using IPv4 addressing can communicate with each other without additional rules. You can apply firewall rules to restrict traffic as needed. 5. Google API access. VMs within a VPC can communicate with Google APIs and services. Private Google access allows instances to reach these services even without an external IP address. 6. Fine-grained IAM. VPC supports fine-grained IAM, identity and access management, supports these policies for network administrators, allowing you to create custom roles with specific privileges for your network team. 7. Deployment models. VPC supports multiple deployment models, including shared VPC for centralized control and VPC peering for connecting networks across projects or organizations. And 8. Hybrid connectivity. You can establish secure connections between your on-premises environment and Google Cloud using VPN or dedicated internet options. So how do you create one? Go over here, click on the bar, go to the VPC network, and then we'll click Create VPC Network. We'll enter in a name for this. Okay. And for subnets, we'll select Automatic. And this will deploy subnets across all the regions. And we can do additional settings. So we can do the network profile. You can see this for specific zones. Okay. We can have firewall rules, which I'll just select default for all. So it's going to be the protocol is going to be ICMP, TCP, and then they'll have egress and ingress rules, right? And we'll have this as regional. We'll have the legacy mode set up, and then PS configuration, we'll just leave this empty, and we'll click create. All right. So it'll create. You can also do this from the command line as well, from the Cloud Shell. Okay. So you'd enter the following: G-Cloud Compute Networks Create, and then the network name, and then subnet mode auto. All right. So that would be an automatic network. Okay. You can also do a custom mode VPC. I'll show you that one as well. All right. We'll go back to the same place, that VPC network here, which I showed you from this hamburger bar, VPC network. Okay. Create the VPC network. Just Kubernetes, custom mode. All right. Custom is selected. And then we'll have the new subnet. Custom mode. More region, US East 1. We'll do that. We'll be IPv4 and the IPv range. We'll do 10.0.0.0/24. All right. You can also do secondary and add additional separate subnets. The secondary IP range would be in case you had an application that was going to exhaust your IPs. Something like a Kubernetes cluster with a lot of nodes could potentially do that. So you want to make sure you have this set up correctly. We're going to select all, have this as set as regional, click create. All right. So this is creating. So the original one, the auto mode is created, and the custom mode is created as well. It's creating. All right. So you can also do this in the command line with the following commands. Let's reconnect here. All right. Enter gcloud compute network create network name, and then subnet mode custom. All right. And you can also add subnets to your VPC with the following commands: gcloud compute network subnet create subnet name, and then the network name, the region, and then the IP range. Hope you can see that there. All right. So network tiers. Google Cloud offers two network tiers for external connectivity, premium and standard. These can be configured at the VPC level. The premium tier routes traffic over Google's global private network, providing optimal performance and security. When users access your Google Cloud services, their traffic connects to the nearest Google point of presence, POP, that location. Google maintains hundreds of POP locations worldwide. From the POP, traffic travels over Google's own managed encrypted private network rather than the public internet, ensuring reliability and security. The standard tier, by contrast, uses a hot potato routing approach, similar to most service providers. Traffic travels via the public internet once it leaves the Google network in the region where your services are hosted. While more cost-effective, this approach doesn't offer the same level of reliability, security, and performance as the premium tier. Google Clouds and regions. Okay. So understanding Google Cloud's geographic organization is important for designing resilient, secure network architecture. Let me see if I can find this. See if we can get a nice image. Okay, this should give you an idea of these regions. Okay, so the regions refer to geographic locations where Google Cloud operates data centers. Each region has at least two zones, with some regions having more zones to provide additional capacity and resilience. The multi-zone design provides fault tolerance and high availability for your applications. To address resiliency and availability, you should design your services to use multiple zones and, for critical workloads, multiple regions. Google Cloud uses a standard naming convention for regions and zones. For example, US Central 1 identifies a region, while US Central 1A identifies a specific zone within that region. Resources in Google Cloud are organized into three scope categories. One, global resources. These are available across all regions and zones within a project. Examples include VPC networks and global load balancers. Two, regional resources. These are available only within a specific region. Examples include subnets, regional managed instance groups, and Cloud Interconnect connections. Three, zonal resources. These are tied to a specific zone. Examples include VM instances, which must be created in a specific zone, though they can access global and regional resources. VPC deployment models. So we've already reviewed this, but let's go back a little bit. Google Cloud supports two main VPC deployment modes, auto mode and custom mode. Let's examine each one and understand when to use them. Let me see if I can find a good image for you. Yeah, this might give you a good idea about it. Okay, auto mode. An auto mode VPC is created with one subnet per region automatically. IP addressing ranges are predefined to use the 10.128.0.0/9 address space. As Google Cloud adds new regions, new subnets are automatically created in those regions. While you can add custom subnets to an auto mode VPC, it's important to note that you can convert an auto mode VPC to a custom mode, a one-way conversion, but you cannot convert a custom mode VPC to auto mode. Auto mode VPCs are enabled by default when creating a project, providing a convenient starting point for experimentation. Here's how to create an auto mode VPC. I've already done this, but let's go back again. Go to create, enter a name right here, all right, enter a description, MTU, auto mode, and then you can add or remove the firewall rules as needed, right? And then you click create. Custom mode VPC. A custom mode VPC gives you more control, allowing you to select specific regions and define custom RFC 1918 based IP addressing ranges for your subnets. This approach is recommended for production environments, particularly when you plan to use VPC peering or establish hybrid connectivity with on-prem networks. So creating a custom VPC network follows similar steps, but with key differences. So you'd set the creation mode to custom, right? And then you can add the description for either one. And then you can do, let's see, the subnets. All right here. You set these per region, okay? And use the the RFC 1918 subnet range. And then you can add a secondary subnet range, which is useful for containers and GKE bods. And then you should, let's see, I'll close that. You should be able to, let me see. Well, this is by the way, you can always find this at the bottom or on the side of each of these pages, how to create this in the command line, okay? And you should be able to create this for regional or global, and then click create. All right. So now we have a shared VPC. But remember, before we get to the shared VPC, custom mode VPCs are strongly recommended for production environments to avoid IP address overlap issues and maintain control over your network. Okay, let's go to shared VPC. Okay. All right, so a shared VPC allows an organization to connect resources from multiple projects to a common VPC network. This network is managed centrally in a host project, while service projects contain the resources that use the network. This approach provides several benefits. One, centralized control. Network admins can manage routes, subnets, firewall rules, and logs from a single location. Two, resource separation. Service project teams maintain control of their own resources while using the shared network infrastructure. Three, billing clarity. Each service project's resources are billed to that project, maintaining cost visibility. So to implement a shared VPC, you first need to assign the appropriate IAM roles. One, so organization administrators can create shared VPC admin roles, and then two, service project VPC admin roles that can be created for specific teams. All right. The shared VPC admin needs both the compute shared VPC admin and the project IAM admin role. So to set up a shared VPC, you go here, choose a project. All right. And then, uh, oh, it's available for an organization. Okay, so I need to set up an organization first. We're not going to do that. It's going to take too much time. Okay. When you save it, then you start to configure it much like you would the auto or custom. Add the subnets, configure permissions for the projects, and then you click create. After creating the shared VPC, you can attach service projects by going to the attached projects tab and then attaching each project. And you specify the project's names to attach. And you set the compute permissions for the service project admins. And then decide whether to share all subnets or individual subnets. Okay, so shared VPC admins can also designate service accounts as the service project admins. These can be user-managed service accounts or Google API service accounts, each with specific formats and permissions. But let me get you some documentation. Okay, shared VPC. Okay, and then I want to find something else for you. RC 1918. Let's find the original. Is it this one? Yeah, this. Okay, you can use that as well. All right, I'm going to bookmark these, bookmark this. I'm going to bookmark this. Okay. All right. So we went to set up this shared VPC, and oh, remember, you can also do this from the command line as well. So here's the command you would do for this. Gcloud compute shared-VPC enable in the host project ID. All right. And then you attach a service project to this with Gcloud compute shared-VPC associated projects, add service project ID, host project, and the host project ID. This uppercase, you would actually fill those out yourself. All right. Please ensure that appropriate IAM roles are assigned to manage shared VPC services. It's very important. Okay, so next we're going into VPC peering. So let's see. There we go. Oh, I didn't see it. Okay, so VPC peering enables direct connectivity between two VPC networks, allowing resources in different projects or even different organizations to communicate using internal IP addresses. Key use cases include allowing your application in one VPC to communicate with services in another VPC without traversing the internet. And two, enabling SaaS providers to expose their services privately to users on Google Cloud. VPC peering offers several advantages. Reduced latency. Traffic stays within the Google network, resulting in lower network latency. Enhanced security. Applications don't need to be publicly accessible, reducing the attack surface. Cost savings. No egress charges apply when traffic stays within the Google network. So important properties of VPC peering include support for Compute Engine, Kubernetes Engine, and App Engine, administrative separation between peered networks, requirements for configuration on both sides, exchange of static and dynamic routes, support for multiple peered connections, and IAM permissions being correct. So before setting up a VPC peering, consider these restraints. IP addresses cannot overlap between peered networks. Let me see if I can get a good article for this for you to visualize. Mhm. Okay, so IP addresses cannot overlap between peered networks. All subnet routes are exchanged. You can't selectively share subnets. Transitive peering is not supported, meaning if A peers with B and B peers with C, A cannot reach C through network B. Network tags and service accounts don't work across peered networks. Internal DNS names aren't accessible across peered networks. Firewall rules aren't exchanged across peered networks. So to configure the VPC peering, we go over here. Okay. You need the following. Okay, continue. Name it. Select your network. This one. Okay. And then you specify the network to peer with Kubernetes mode, right? And then choose whether to import or export custom routes. I think we're going to leave that safe. Okay. And let me go over here. Let me see if I can do this. And then go here, good connection. Okay. It's custom mode. And project here, and project here. Peer with this. Create. Create. All right. Remember, peering is completed only when configured on both sides. You can modify or delete peers as required. There you go. Looks like they're active. All right. You can also do this with the CLI commands. You knew I was going to show you that one. All right. So to do that, okay, this would be the configuration for one, Gcloud Compute Networks peering create, the peering name, the network name, project ID, the network name for the network you're connecting to, right? Or your network that you're connecting from, project you're connecting to, network you're connecting to, and the auto create routes. And then on the other side, you would then the same from the other side, G-Cloud Compute Networks create peering name, network B to project A to project A, or to network A, okay? Okay, so micro-segmentation. Micro-segmentation involves creating subnets, defining custom routing, and using firewall rules to establish security boundaries within your VPC. This approach enhances security by limiting lateral movement within your network. Subnets. So what are subnets? Subnets are a fundamental building block for network segmentation. Google Cloud supports two types of CIDR ranges for subnets. Let's go over here. Let's see. Why don't I see subnets? Here. There we go. Okay, so subnets. We'll add this to chat log, so you can always go in there. Okay. So there's a primary CIDR range. This is mandatory for each subnet. VMs, load balancers, and other resources get IP addresses from this range. While you can extend a primary IP range, you cannot reduce its size. Two, the secondary CIDR range. This is optional, right? This is typically used to allocate IPs to microservices like containers. Secondary ranges are fixed and cannot be extended. So this goes into a place where you want to have more resources available for something like containers. Kubernetes engine can eat up a lot of these subnets very quickly because there's a limited amount. Okay, custom routing. So custom routing allows you to define how traffic flows within your VPC. Google Cloud supports three types of routes. One, system generated routes. These are created automatically by the system. These include routes for subnet communication, peering exchanges, and cloud router connections. Two, static routes. These are added manually by administrators. These are useful for defining next hops like internal TCP UDP load balancers or cloud VPN connections. And then three, dynamic custom routes. These are updated dynamically, such as through BGP peering via cloud router. The next hop is always a BGP peer. Let me see if I can get a good article for you. Okay. That would probably be it. Yeah, that's it. All right, and you can go by here. You see the route types goes in a little more detail. Okay. And that'll be in the chat as well. And I'll book that for myself as well. So it's important to note that you shouldn't apply custom routes directly to individual instances as they won't persist when the instance reboots. Instead, apply routes at the network level using tags of service account or service accounts if needed. Firewall rules. All right. All right. So let's see. This is probably going to be in here. Okay. Oh. This will be down here. Okay. So firewall rules. Let's go in here. Firewall rules are a critical component of network security in Google Cloud. They determine which traffic is allowed or denied between resources in your VPC. Key characteristics of Google Cloud firewall rules include one, stateful operations. Firewall rules are stateful, meaning if you allow a connection in one direction, return traffic is automatically permitted. Two, host level enforcement. Rules are enforced at the host level, resulting in negligible performance impact. Three, controlled paths. Firewall rules can manage traffic between VMs and the internet, and between VMs and on-premises resources. Four, implied rules. Every VPC has two implied rules that cannot be deleted. One that blocks all incoming connections and another that allows all outgoing connections. Five, exceptions. Some exceptions exist, such as outbound traffic on port 25, that's SMTP, being denied by default, and communications with the metadata service at 169.254.169.254 being allowed. Six, IPv4, IPv6 separation. Firewall rules can include either IPv4 or IPv6 addresses but not both in the same rule. 7. Action and status. Each rule has an allow or deny action and can be enabled or disabled as needed. 8. Protocol tracking. All firewall rules are tracked regardless of protocol. So components of a firewall rule include direction, that's ingress, like incoming, or egress, outgoing. Priority, this determines the rule precedence, meaning lower numbers have higher priority. So 0 has a higher priority than 100. 100 has a higher priority than 1000. The action, that's whether it allows or denies. The enforcement status, whether it's enabled or disabled. The target, this specifies which instances the rule applies to. The source or destination, this filters for traffic origins or destinations. The protocols and ports, this specifies the traffic type and connection points. And then the logging, optional logging of matching connections. During rule evaluation, Google Cloud processes rules according to their priority, with the lowest number being the highest priority, evaluated first. If no rules match, the implied rules take effect. So Google Cloud supports several options for defining firewall rule targets. 1. 5 tuple-based rules. This defines rules based on source IP, destination IP, port, protocol, and action. 2. Network tag-based rules. This associates rules with network tags assigned to instances. And 3. Service account-based rules. This targets rules based on the service account associated with instances. So to create a firewall rule, go to Firewall. We'll click Create Firewall Rule. Provide a unique name. Turn on logs. Yeah, logs are good. They'll cost, set the priority, right? 1000 is higher than 10,000, right? But 100 is lower than 10 on the priority list, okay? Select the network. We have 3 networks available, right? Select the 2 we just created or the default. Direction of the traffic. Select the action. And then we can add targets. All right. Create tags. Create filters for the IPVs. I'm not going to create this, so don't worry about that. Ports and protocols, we can just select all, right? We're not going to typically do that, right? And then you can have some rules for enforcement, enabled or disabled. And then you would click create, okay? I'm going to cancel that though. And remember, you can also do that through the CLI with the following. G-Cloud compute firewall dash rules create, and then a rule name. Then you select the network name, the ingress, priority, the action, the rules for ports and protocols, the source ranges, and then add target tags. All right. So let's go to Cloud DNS. Cloud DNS is Google's scalable, fully managed domain name service, domain name system service, supporting both public and private zones. Every VM instance has access to metadata server that acts as a DNS resolver for both internal and external name resolution. Cloud DNS supports several advanced features. Let's see if I can find this. Okay, so Cloud DNS supports several advanced features. 1, split horizon DNS. This allows different name resolution depending on whether the query comes from inside or outside your VPC. 2, DNS forwarding. This enables requests to be forwarded to an on-prem resolver for hybrid environments. 3, DNS peering. This allows querying of private zones in different VPC networks without requiring direct network connectivity. 4, managed reserve zones. This prevents non-RFC 1918 address resolutions from being sent to the internet. 6, DNSSEC. This adds authentication to DNS responses, helping prevent DNS spoofing attacks. 7, resolver policies. This configures access to private and restricted Google APIs within VPC service control perimeters. Internal DNS records are automatically created for VM primary IPs. For example, a VM might be assigned a name like instance.us-west-1b project.internal for resolution within the same VPC and project. Okay, so let's go into how do you configure Cloud DNS. So one, ensure you have a domain registered in your name. I do, but I don't want to. I do have that, but I don't want to expose it. So I'm just going to point this to you a little bit. All right, so create the zone, enter the zone name, enter the DNS name. So this would be like the domain you own. Think google.com, dns.com, zone.com. You own this. You need to buy this, right? Select the DNS sec, okay, and then let's say on. Or you could transfer it. Yeah, but I don't want to do that. You can do cloud logging. That's always a good idea. And then click create. Okay. And you can do this from the CLI. All right. So the example, yeah, the code you'd put would be cloud DNS manage dash zones, create, and then the zone name, and the DNS name, description, and the visibility. Right. So you'd be good. All right. So DNSSEC. Actually, wait, did I put something for Cloud DNS in here? Hmm. Okay, there we go. There's some documentation. All right. I'll add this to my resource. Okay. Okay. So we're going to DNSSEC. All right. So you'd have to activate this for your domain, and we'll add this. Okay. In the chat. Okay, so DNSSEC is domain name system security extensions. This is a security feature that prevents attackers from poisoning or manipulating DNS requests. When you enable DNSSEC for a zone, Cloud DNS serves the public key, the DS key, and the resource record signatures, the RRSIG, and the non-existence INSEC parameters to authenticate your zone's content. For DNSSEC to work effectively, your domain registrar must support DNSSEC for your top-level domain, and you must be able to add a delegate signer record through your registrar. Note that DNSSEC provides authentication, not encryption. The keys are used to verify the DNS resolver, not to encrypt the queries and responses themselves. If you're migrating a DNSSEC sign zone to Cloud DNS, use the transfer state when enabling DNSSEC. This allows you to copy your key signing key and the zone signing key from your cloud old zone to Cloud DNS. Add this to, add this. All right, so we're going to go over my next piece, load balancers. Oops. Okay, so load balancers. Okay, I'm going to close that. All right, so Google Cloud offers several types of load balancers to distribute traffic securely across resources. One, the Global External HTTPS Load Balancer. This is a proxy-based Layer 7 service that handles HTTPS traffic. It can distribute traffic to various backend services like Compute Engine, GKE, and cloud storage using a single external IP. Two, the Regional External TCP UDP Load Balancer, also known as a Regional Network Load Balancer. This serves as a balance traffic. This serves as a balance for traffic for VMs in the same region. It's a pass-through service, not a proxy. So using the packet source and destination information for distribution is priority. Three, the SSL proxy load balancer. This is a global reverse proxy that distributes SSL traffic to backend VMs. It terminates incoming TLS requests and can forward traffic as either TLS or TCP. Four, TCP proxy load balancer. This is similar to the SSL proxy, but for general TCP traffic. It uses a single external IP for all users globally and can route traffic as TCP or SSL. 5. Internal TCP UDP load balancer. This distributes traffic to internal VMs within a region in a VPC. It's useful for multi-tier architecture with private backend services. 6. The internal HTTPS load balancer. This is a regional proxy-based layer 7 load balancer for internal traffic built on the open source Envoy proxy. Load balancers can be categorized as either external, meaning handling traffic from the internet, or internal, for traffic within your VPC. They can also be global, meaning they're distributing traffic across multiple regions, or regional, limiting to backends in a particular region. All right, so we can configure this. I'll give you a little example. Go ahead and load balancers. Okay, create a load balancer. You choose the basic type you're looking for, application, network. So let's go for application, click next. So it'll be public facing or internal. We'll stick with internal, or I'm sorry, external. Okay, go for global or single. Global, we'll stick with global. It's gonna be expensive load balancer when we're done. And then the load balancer generation, global external, classic application. We'll go for, we'll stick with global external. All right. And then you'd click configure and it would be created. And it takes about 5 to 10 minutes for this to create. So we're going to click cancel. And remember, you can create it from your CLI. Let me see. It should be, is it here? No. Can't you create it from your CLI? Advanced menu. Maybe you can't. Ah, well, that's okay. We'll keep moving forward. All right. So hybrid connectivity options. Okay. So all right, let me find something for you. I mean, I know where this is going to lie, but let's see if I can find a good image for you. Okay, this is going to be a good one. I could see this. This is nice. All right. I'll add this to the chat. This is where you can actually get this done. All right, so let's go back to this. All right, so hybrid connectivity allows you to join your Google Cloud network with your on-premises network or third-party cloud providers. Google Cloud Router, a managed regional service, exchanges routes between your VPC and on-premises network using Border Gateway Protocol. That's BGP. Two primary options for hybrid connectivity are Cloud VPN. So Cloud VPN creates an IPsec-based connection over the internet between your Google Cloud environment and your on-premises network or another cloud. This is often the fastest and easiest way to establish secure connectivity. It supports 1.5 to 3 gigabytes per second per tunnel, depending on the peer location, offers multi-tunnel support for higher bandwidth, requires a VPN device at your on-prem data center that supports IPsec IKE protocols, and works with both static and dynamic routing. And it provides high availability options using multiple interfaces. Let's go over here. Network services. So we go Cloud VPN. Why am I not finding it? Let's save this. Add this to the chat. Oops, didn't mean to do that. There we go. VPN. All right, so you create the VPN connection. You decide between high availability or classic. This is based on your requirements for how you want this connected. And then click continue. Name your VPN. Which network would you select to connect to your hybrid? And then what the region is going to be. All right? You choose IPv4 or 6, and then you create and start to add the tunnels, configure the BGP, and have additional commands there. All right. You can also create this from the command line. Okay. Could be this gcloud compute target dash VPN dash gateways create, and the gateway name, network name, and the region. Okay. And you could reserve a static external IP address that would be useful for this. All right. gcloud compute addresses create the address name and the region. All right. And you can create a forwarding rule for the VPN. All right. gcloud compute forwarding rules create forwarding rule name, the IP protocol type, the address name, the gateway name. Okay. And then you can create the VPN tunnel. All right. Which is what we showed on the GUI. All right. That would be gcloud compute VPN tunnels, create tunnel name, the peer IP, the IKE version, the shared secret, the gateway name, the local traffic, and then the remote traffic and region. Okay. Next, we'll go into Cloud Interconnect. Oh, I just passed it. The Cloud Interconnect. Okay. Oops. Okay. So Cloud Interconnect establishes a dedicated private link that doesn't traverse the public internet. So this provides direct access to internal IPs in your VPC from your on-premises network, right? It eliminates the need for VPN or network or NAT, network address translator, and it supports high bandwidth, so 8 by 10 gigabytes or 200 to 100 gigabyte per second connections. It also reduces egress costs as traffic remains internal. It works with private Google access for API access, and it uses unencrypted traffic by default. So you can add your own encryption if you need. It uses VLAN attachments associated with the cloud router, and it requires multiple connections for redundancies, right? So configuring Cloud Interconnect is Cloud VPN to the next level, right? But remember, the best practice is establish connections from multiple on-prem locations to different co-location facilities for redundancies. So here's some best practices and design considerations. And okay, when designing your VPC architecture, consider these best practices. One, prevent overlapping IPs. Create VPC networks using custom subnet creation mode for better control. Two, use shared VPC. Reduce management and topology complexity with shared VPC where possible. Three, group similar applications. Use fewer, larger subnets for similar applications rather than excessive segmentation. Four, apply organization policies. Skip default network creation for new projects, restrict shared VPC host projects and subnets, and restrict VPC peering usage. Five, consider limitations. Ensure your design scales by understanding component limitations. Key decisions to make when designing your VPC will include how will the resources communicate with each other? This is going to be the VPC design, or you're going to use a shared VPC. How will resources be segmented into networks and subnets? How will name resolution work between cloud resources and connected environments? What strategies will connect Google Cloud with corporate networks? How will resources communicate with the internet? By addressing these questions and following best practices, you can thoughtfully build a resilient and secure network architecture in Google Cloud that meets your organization's requirements. VPC provides the foundation for securing networking in the Google Cloud. By understanding the components, deployment models, the security features, you can design an architecture that protects your resources while enabling the connectivity your applications need. So I'm going to say thank you for chapter 7 on the VPC. The next chapter we're going to do is going to be advanced network security in Google Cloud Platform. We'll talk to you soon.